Get on to question 4. We've got a partial fraction question, and it tells us what it wants you to do. And unfortunately, however, from the 3 that I've marked, nobody spotted the first 3 words by dividing first. One of the details of the partial fractions chapter that we did was if you've got an order on top which is the same or greater than the order on the bottom, then you need to divide first. When I say divide, we're talking about algebraic long division. What's the order on top? It's the highest power, x squared. What's the power on the bottom? It's a quadratic, isn't it? X squared. So the clues are there. By looking at those and checking that, you know to divide first. However, in case you forget, it tells you to do it. If this comes up in the exam, please remember. So you can see from the solutions that I've done algebraic long division there, and if you do a lot of these, you get used to spotting that it's an x squared on the bottom, it's an x squared on the top, but it's got a coefficient of 3. So we're going to get a whole number of 3, and then the division tells you what the remainder is going to be. And we end up with a remainder of 2x plus 2, and that is over x minus 1, x minus 3. And then this part here, that is what you turn into partial fractions, which you can do, which you can all do. So I don't need to labour that one. So question 5, we're given a function here, the f of x, and we're told to calculate f of 2. So we substitute 2 in, and in the exam you show you're working as I did on the solutions, but you find that equals 0. And the key thing we can learn from that is, you know the factor theorem, don't you? That x minus that value must be a factor. So that should come to mind as soon as you find that equals 0. And that helps you with part .ei2. Write it as the product of 2 algebraic factors. In other words, f of x equals one algebraic factor times another. Because that equals 0, you're expected to realise that therefore that is one of our factors. How do we find the other? You've guessed it, by algebraic long division. And so, as on the answer sheet, you then divide f of x by the factor that you know. And we find that the other factor is minus 3x squared plus 2x minus 5. We've got our 2 algebraic factors. Possibly when you get to this stage, you look at it and think, oh, can I factorise that into 2 linear factors? You don't need to do it for the question, but when you get a quadratic, that's a question which should be at least at the back of your mind. And we'll come back to that in a moment. We move on, and it says using the answer to a.ei2. Big clue there. In any question, you might find that one part of the question uses what you've worked out in a previous part of the question. So again, something to have in mind in the exam. But having worked with the f of x, and you're given this new function, you should notice that the coefficients are the same as the coefficients in the f of x. What's different? The difference is that instead of x's we've got y's, but the powers are doubled for each term. If the powers are doubled for each term, then there's that consistent relationship between the y's and the x's, and y squared we have y squared instead of x. That's the difference. So there's a relationship between the two functions. And so what that means is we can factorise this the same way as we factorise this one. So if we said let y squared equals large X, then we've got a very similar equation to what we've got here, minus 3x cubed, so that's y squared to the power of 3 is y to the 6, so that is equal 8 times x squared, 9 times x. And so now we've got a function which is essentially the same as that. So that equals, when we factorise it, the same as our answer to part A. So we're using that now. If we want two solutions to it, well, first of all, x minus 2. That means, I should have used a capital X there, x minus 2 equals 0, therefore x equals 2. How about this factor here? Has it got, can we factorise it, or can we find two solutions to it? Well, the discriminant will tell us if we can. We can work out the discriminant as I have in the solution. We find that that equals minus 56. As it's less than 0, there's no real solutions for x. So where does that leave us? We're told to prove there's exactly 2. We know there's none from that bracket. We've got x equals 2. This is where we remind ourselves x, and this equation is y squared. So we can say y squared equals 2. Therefore y itself, if we find the square root of 2, it's got the 2 roots. We've proved there's exactly 2 real solutions. 2 possible solutions and no more as required. Okay, that's the answer to 5. In terms of the test on data, I don't think I can add much to it by talking through it other than what I've written down. But if you do have any questions, do get in touch.